Here is our first lesson of chapter 2. We're actually going to combine two lessons today. We're going to cover 2.1 and 2.2. But the reason we're doing that is because the topics covered in both of these lessons should be pretty familiar to you. I think you'll recognize all of them. And so it's easy to kind of combine them and go through this lesson without dragging it out too much. So 2.1 and 2.2. 2.1 is all about perpendicularity, and 2.2 is about complementary and supplementary angles. So we're going to really focus on remembering what perpendicular is all about, and then we're going to work on recognizing complementary and supplementary angles, and then using that idea of complementary and supplementary angles in order to solve some problems. So that's going to be our lesson focus for today. Okay, so we started with our warm-up. Hopefully you've taken a look at it already. So this kind of brings us back to that idea of perpendicular from algebra last year. So this says that the equation of the red line is y equals 2x plus 4. So the red line is y equals 2x plus 4. Over on the left it says which graph shows a line perpendicular to the red line, and drag it into the blue box. So first of all, in the warm-up, it wanted you to remember what perpendicular lines looked like. And then over on the right, it said what would be the slope of a line perpendicular to the red line, and drag that one into the green box. So if you haven't done your warm-up yet, if you're looking at your slides in presentation mode, just click it out of presentation mode. You should be able to move those graphs around and slide them into the right spot. Same with those green boxes for the numbers. Take a shot at it now. Pause the video if you haven't done it yet. All right, if you did do it, we have to first start off by remembering, what does perpendicular mean, right? So I know that perpendicular means intersecting, right? So there's one graph already that I can for sure cross off, and that would be those lines that are parallel. These are not perpendicular lines. Those are parallel lines, right? So that was definitely not one. Okay, so then I have intersecting lines up on the top, and I have a different kind of intersecting lines underneath. So remember that perpendicular doesn't just mean intersecting. Perpendicular actually means that they intersect to form right angles. So we're looking for that nice perfect corner, right? So this was actually the diagram or the graph that's showing a line that's perpendicular to the red line. The one on the top here, this was just intersecting, but not perpendicular. Okay, so remembering what perpendicular actually meant. Okay, so then we have to get back to, on the right-hand side, is what would be the slope. Now, this is something we talked about last year in algebra. So the slope, so a lot of times people remember the slope of parallel lines. Parallel lines have the same slope, and it really helps when you look at that picture to see that those are going in that same direction, right? They just start in a different place. So parallel lines have the same slope. Perpendicular lines definitely can't have the same slope. So the slope of my red line here, slope was 2, right? So we know for sure that I can't have the same slope. So if I look at the slopes, you can even use your graph over there that you found as an example. So I know that the red line has a positive slope, and I can see that the blue line is definitely going to have a negative slope, right? So that one's out. So I know that my slope has to be opposite for sure, right? But the blue line on the top also had a negative slope. So it was opposite, but it wasn't perpendicular. So hopefully by now some bells are ringing and you're remembering that the slope of perpendicular lines have to be opposite and reciprocal. Opposite reciprocal slope. So if my slope of my original line was 2, or in other words 2 over 1, then I need to have my new slope be negative, and I need to have the reciprocal, meaning flip it upside down. So my new slope would be negative 1 over 2, which would be that one right underneath it. So -1/2 would be the slope of a line perpendicular to y equals 2x plus 4. Hopefully you remembered that back from algebra. Is a good way to really incorporate that with our perpendicular lesson that we're going to talk about today. So actually, as we were talking about there, we remembered what the word perpendicular meant. So here we have the definition of perpendicular. So yes, you do know that this is a definition here. Whoops, didn't mean to write with my highlighter. This is a definition. Do you remember what it means if we say that we have a definition? It means that it's reversible, right? So as you can see, I have the original conditional statement and also the converse both listed for you here. So my definition of perpendicular: if two lines, segments, or rays intersect to form right angles, then they are perpendicular. So these words two lines can be swapped out with any one of these other words, segments or rays, right? So we don't use all three of them when we write this down in a proof. If two lines intersect to form right angles, so again here, this can be swapped out, right? Then they are perpendicular. What else could we say instead of just saying form right angles? Another thing that we could say is that they form 90-degree angles. So that could be swapped out for 90 degrees depending on what you're given in your proof. Okay, so the original says if two lines form right angles, then they're perpendicular. The converse then says if two lines are perpendicular, then they form right angles. Okay, so you notice there's the converse. We talked a little bit about that back in chapter 1. So just depending on whatever you are given in your proof, whatever you need, you can use line, segments, rays, whatever, and then 90-degree angles or right angles, whatever you're given. But just remember the if part has to be whatever is in a statement before that. The then part is what you're trying to say in this step. All right, so we remembered kind of what perpendicular meant already. There was just the if-then form. It means that they form right angles, right? So here's an example. In this picture, you are given that segment AC is perpendicular. Here is maybe something new to you. I'm not sure if you know this one yet. This right here is the symbol that means perpendicular. This is symbol for perpendicular. This is a symbol that we use a lot, okay? So it's an upside down T. That means perpendicular. You kind of see how it's making those right angles, right? So use that symbol, get comfy with it, use it whenever you'd like to instead of writing out that big long word perpendicular. This is a good one to remember. Okay, so segment AC is perpendicular to segment AS. And now it says, what are the conclusions? So if you look at that picture, based on the given, what do you know about the picture? Don't write out things that we can assume from the diagram. Angle CTS is a straight angle. Sure, you're right. But just based off of that given, what do you know for sure about your picture? Go ahead and pause your video and see what you can come up with. All right, so a lot of times, I will get first responses here. Will say that my conclusions are that angle ATC is congruent to angle ATS. Oops, forgot my angle symbol there. Angle ATS. I get that angle ATC equals 90 degrees. Well, that says that these angles down here and angle ATS equals 90 degrees. Those are very common ones. Then I also get ones that say angle CAS equals 90 degrees up here. So the question is, which ones of those are right? So this comes back to being very careful about your given. This says that segment AC is perpendicular to segment AS. Those are the segments that are perpendicular. So which one of these conclusions is true? Only angle CAS equals 90 degrees. This is the only conclusion, This is the only conclusion that works here. These other ones are easy for your brain to think, but they are not true. That would be different things, right? This is no good. That would mean that segment AT was perpendicular to segment CS, right? That's not what the given told us. So be careful. It's not just the angles that look like they're right angles, right? It's got to be the angle that's between the two segments that you're given that are perpendicular. So angle CAS is the correct conclusion here. But we could also say, if we know that it's a right angle, then we could also say that angle CAS is a right angle because we knew it was a 90-degree angle. So these two are good, but the ones down at the bottom are no good because those are different segments that would be perpendicular. So be careful on what your given says. All right, so the second part of our lesson then is about complementary and supplementary angles. Hopefully from last year you remember this, right? So complementary are two angles that form a right angle. Now I'm guessing from last year you probably weren't thinking in terms of right angles, right? You were probably thinking in terms of 90 degrees. So you could swap out those words, form a right angle with two angles that add up to 90 degrees. Then they add up to 90 degrees. So again, this is a definition of complementary. So if two angles form a right angle, then they are complementary. Or if two angles add up to 90 degrees, sorry, I shouldn't say that. If two angles add up to 90 degrees, then they are complementary. And then the converse, if two angles are complementary, then they form a right angle, or then they add up to 90 degrees. So complementary angles add up to 90 degrees. Hopefully you're remembering. Supplementary angles, again, our definition. Supplementary angles add up to 180 degrees. So now we think of that now as forming a straight angle, right? So if two angles form a straight angle, then they are supplementary. But you could swap out your words, form a straight angle, with add up to 180 degrees. If two angles add up to 180 degrees, then they are supplementary. If two angles are supplementary, then they form a straight angle. Or if two angles are supplementary, then they add up to 180 degrees. So remember, these things that you can swap out just are whatever you're given in your proof. It's only when you have to do a proof, right? It's whatever you're given in the proof that you need to make sure line up exactly to make your wording and your vocabulary match. So you can swap out depending on whatever you need, right? They mean the same thing, so now you can just swap out the words. So complementary angles add up to 90, supplementary angles add up to 180, and hopefully you remembered that from last year. So now it's just how are we going to use that, right? So here I have a proof for you using the perpendicular theorem and that complementary definition, perpendicular definition, to just remember and realize and work through how do you use that in an actual proof. So you're getting the hang of proofs now, right? So you could probably attempt this one on your own. When you're done, you could keep watching the video. I'll go through it with you. You could check your answer by clicking that little blue word on answer, and that's a link to the actual answer key for this problem. And just remember that at this point we're starting to get to some longer, maybe more complicated proofs, so it's okay if some of your steps are in a different order. That's fine. As long as your ifs and thens match up, you're good to go. All right, so if you want to pause it now and take a shot at it, go for it. Okay, so in this proof, it says that we are given segment MA is perpendicular to segment AT. MA is perpendicular to AT. Okay, and I'm trying to prove that angle 1 is complementary to angle 2. So I'm going to start with my given here. I'm going to zoom in a little bit. Step 1, MA, segment MA is perpendicular to segment AT. Given. Okay. Well, if I know that these two segments are perpendicular, then with my definition, I know that they are forming a right angle, right? And remember from our example one there, we got to be careful. It's the angle that's in between, or the angle formed by those two segments. So step 2 would say that angle MAT is a right angle. Now the reason for this is our definition of perpendicular, right? But remember, the if part needs to be a step that was before that. So if they are perpendicular, if two segments are perpendicular, using that symbol wherever I can, and the then part is what's in this step, then they form a right angle. Okay, so make sure that you have the if and the then in the correct order, but also double check that I use the word right angle in my statement, so I have to use the words right angle in my reason. Now, if you said angle MAT equals 90 degrees in your statement, awesome, perfect. Then you just have to stay in your reason, then they form a 90-degree angle. So you got to make sure that they match. Whatever you pick to use is fine. You just got to make sure that you stick with it all the way through. All right, so now that I know that I have a right angle, I'm trying to prove they're complementary. Ooh, I think I can do that now, right? With my definition of complementary. So step 3, angle 1 is complementary to angle 2. And the reason is, remember, the if part has to be what has come before it in a statement. So if two angles form a right angle, because that's what I've just finished saying in the step before it, and the then part is what I'm saying in the step right now, then they are complementary. Notice we are abbreviating complementary. That's perfectly fine. Comp is pretty obvious on what we're talking about. You can abbreviate supplementary to sup. That's okay. That happens a lot too. There we go. And notice here on this one, again, I had to use good vocabulary. My vocabulary there says right angle because that's what I picked to do from the beginning. Now, if you picked 90-degree angle there and you used it in your reason on step 2, excellent. Then on your reason on step 3, you'd have to say if two angles add up to 90 degrees, then they are complementary. Remember that our proofs are based on that specific structure, and that deductive structure is based off of good vocabulary. So making sure that you match up your vocab all the way through. Okay, so that one wasn't too bad. Hopefully you got that right. And if you didn't, hopefully you understand what went wrong and you're kind of fixing things up and tweaking as you go. All right, so those proofs seem to be pretty straightforward because they're theorems that are definitions that you've heard before. So here's another way that we see this complementary and supplementary a lot, and that's in these word problems. And I know you guys can do these because you did them last year for sure. This says the measure of one of two complementary angles is 3 greater than twice the measure of the other. Find their measures. So we need to find both of the angles. There is more than one way to do this problem. Why don't you pause and see what you can do? Okay, now, one way to do this that a lot of people start with is by drawing a picture. Okay, so if I say that I have complementary angles, that means my picture is going to start with a 90-degree angle, and then I'm going to split it, right? So 90-degree angle and split it. So one of the two complementary angles is 3 greater than twice the measure of the other. So the other will just be x, and then the one would be 3 more than twice the measure, so 2x plus 3. And if I know that they're complementary, then 2x plus 3 plus x, right, the two of them added up, has to equal 90 degrees. Oops, I don't usually like to label in my work. So that's one way to do it. Or you could have set this up as a system. And you could have said x plus y equals 90 because they're complementary. And then we could say one of them, x, equals, oh here, actually, let's do y. Usually you guys do that. Y equals 3 greater than 2 times the other, so 2x plus 3. And then you could use substitution. Substitute this 2x plus 3 in for y here, and guess what? We're right back at the same equation. So using the picture and using one single variable, or using a system and substituting, you end up in the same place. So however you wanted to do it was perfectly fine. So at this point now, let's see, I'm going to combine my like terms. I get 3x plus 3 equals 90. I am going to subtract 3 from both sides. I get 3x equals 87. I'm going to divide by 3 on both sides, and I get x equals 29. All right, so one of the angles was x, so x equals 29 degrees is one of my answers, but that's not the only answer. I also need to figure out what the other one was, and that was 2x plus 3. So 2 times 29 plus 3 would actually be 58 plus 3, which gives me 61 degrees. And now we could just double check. They're supposed to be complementary, right? Does 61 plus 29 equal 90? You bet. So there's our correct answer. Don't forget to throw those labels on there too, right? These are angle measures, so I have to put my degrees in there. All right, so that was one just to get you used to and kind of get back in the swing of things. You know, you can set up a system if you want to, or you draw a picture and don't have to set up a system on that one. That one was fine. Here's another one for you, and this one maybe kicks it up a notch. The measure of the supplement of an angle is 30 degrees less than 5 times the measure of its complement. What's the measure of the complement? All right. On this one, you have both the supplement and the complement. I will give you a hint. This is very difficult to draw the picture of, so don't feel like you need to draw the picture on this one. And you definitely need to define your variables. Why don't you pause and see if you can get this one? All right, so defining your variables on this one is something we had to do last year a lot, but it's something that kind of takes a little while to come back. So we need to define what our angle is going to be, what our complement is going to be, and what our supplement is going to be, right? Because we're talking about all of those things in this problem. Now, if you can't really figure out what you're going to call them, try this. What if I told you that my angle was 10 degrees? What would be the complement? Well, I would in my head say, well, 90 minus 10 equals 80 degrees. Okay. And if the angle was 10 degrees, what would be the supplement? Well, in my head, I would say it's 180 minus 10 degrees, so it'd be 170. Okay. Well, what if my angle was 20 degrees? Well, then the complement would be 90 minus 20, which is 70 degrees. And then the supplement would be 180 minus 20, which is 160 degrees. Okay, so we're seeing the pattern. What am I doing in my head every time? So I don't know what the angle is. So this time I'm going to call the angle x. So what was I doing? I was doing 90 minus 10. I was doing 90 minus 20. So this time I'm going to do 90 minus x, right? X and 90 minus x add up to 90 degrees. That's how I know that the complement would be 90 minus x. And what would be the supplement? Well, if the angle is x, the supplement is 180 minus x. There are my variables that I'm going to use right here. Okay, so this you can just kind of ignore now because those were just my examples, right? So the angle is x, the complement is 90 minus x, the supplement is 180 minus x. Now you don't have to go through those actual number examples unless you forget how to define your variables, but hopefully walking through it a little bit reminded you of how we did that last year, because that is review. So now just remember, if you have the complement and the supplement in the same problem, pull out those variables and go from there. So it says the measure of the supplement, so the supplement of an angle is, okay, so supplement 180 minus x is where I put my equal sign, 30 degrees less than 5 times the measure of its complement. Okay, so let's see, 30 degrees less than 5 times. So I have 5 times something minus 30, right? Remember those words, less than. Got to put the 30 degrees on the other side. It's not 30 minus, it's something minus 30. Okay, 5 times the measure of the complement. So the complement is 90 minus x. So there we have our equation, and now all we have to do is solve it. Okay, let's distribute. There we go, now I got it. Distribute my 5, so I get 180 minus x equals 450 minus 5x minus 30. I'm going to combine some like terms before I start moving stuff around. I get 180 minus x equals 420 minus 5x. All right, now I'm going to add 5x to both sides just to get my variables together. I've got 180 plus 4x equals 420. I'm going to subtract 180 from both sides. I've got 4x equals, let's see, 420 minus 180 is 240. I'm going to divide both sides by 4. I'm going to get x equals 60. All right, is that what I was trying to find? X equals 60? Ooh, no. It says that I am trying to find the measure of the complement. So x is not my answer. My answer is 90 minus 60, which gives me 30 degrees. That's what the complement measures. Okay, so big one on that one is remembering how to set up those variables and then turn those words into an equation step by step, right? And then solving. And again, that's review. You did it last year. I know you can do it again. You just had to remember how to do it. All right, so we did a lot with our perpendicular, complementary, and supplementary. We wrote a proof. We practiced some problems. I think you'll be okay. So just to wrap it up, remember that those perpendicular lines form right angles or 90-degree angles, however you want to think of it, right? But be careful that you're reading carefully on which two lines are perpendicular, and the right angles are what's formed by those two lines, and that's it. Complementary angles add up to 90, supplementary add up to 180, and when you're solving those word problems with complementary and supplementary, make sure you set up those variables first. All right, now technically we did 2 lessons here, so you do have some homework from each of those pages, or it's only one from 2.1 because perpendicular gets used a lot actually when you start doing complementary and supplementary, so it'll be built in a little bit to those 2.2 problems. So those 2 up there in gray, you have to do those. So number 6 from page 64, and then 7, 8, 9, 12, and 22 from page 69. All of those are your homework for tonight. The other ones are additional practice. Notice there's a ton of additional practice if you would like it for 2.1. If one problem isn't quite enough for you to make sure that you're solid on it, then go ahead and do those optional extra practice on that one, or your complementary and supplementary ones as well.